Web applications are increasing in popularity as the web continues to grow. Companies accept payments, bills can be paid, and even our shopping can all be done online. A recent security study debunked the myth that most attacks come from within an organization, and further revealed that most of the network breaches originated from web application attacks. This makes sense, as a dynamic web application will usually provide a larger attack surface, as the web server often runs server-side code. Depending on the quality of this code and the configuration of the web server, the integrity of the site may be compromised by a malicious visitor. Web applications can be written in a variety of languages, each with its specific vulnerability classes, although the main attack vectors are similar in concept. This module introduces several web application attack vectors in Windows and Linux environments. But keep in mind that the topic of web application attacks is vast and complex. This module will discuss the basic attack vectors using simple examples. Before I begin this module, I'll install a couple of useful plugins in my browser, which are generally useful to have during a web assessment. The first plugin is called Cookies Manager Plus and provides us a useful interface to edit and manage our cookies. And our second plugin is called Tamper Data, and we'll be seeing this plugin later on in the module. Now that the plugins are installed, I'll connect to my Windows lab machine and start up my WAMP stack. I'll run the XAMPP control panel with administrative privileges and then start Apache and MySQL. I'll now browse to the guestbook web application hosted on my Windows 7 lab machine, and there we'll meet a simple guestbook web application which allows users to post their name as well as a comment. The problem here is that the web application does not filter any input, allowing us to include our own HTML or JavaScript code into the output page. I'll post a message in our guestbook and try to inject some JavaScript into it. And in this case, the JavaScript will simply try to pop up a message box on the victim's browser. And let's send this to the web application. Now that I've injected my JavaScript, I'll have an unsuspecting victim browse to this web page, and my injected JavaScript is executed on their browser. Let's see what type of impact this can have on potential victims. XSS vulnerabilities often go hand in hand with client-side attacks, as they allow for the redirection of the victim's browser to a location of our choosing. Alternatively, we could choose to inject an invisible iframe into the victim's browser to get the same results in a stealthier manner. The following HTML code will create an invisible iframe, which creates an HTTP connection with my attacking machine on port 81. Let's see what happens once this input is submitted and the victim browses this page. I'll set up a listener on my attacking box on port 81. And as the victim, I'll go ahead and refresh the comments page. Once our victim visits the affected page, their browser connects to our attacking machine on port 81 in an attempt to open up the iframe. This browser redirection technique can now be used to redirect the victim to client-side exploits, gather information about their browser, or steal any cookies or authentication tokens the victim may have. Let's take a look at that and try stealing some authentication cookies. I'll have the victim log into the administration panel with username offsec and password 123456. And once the authentication succeeds, a cookie that contains a PHP session ID is added to this administrative session. Any further attempts to access this administrative page do not require re-authentication, as the session has already been authenticated. Using some injected JavaScript, we can have the victim's browser send us their cookie information, thus getting access to their authentication tokens. Let's see how we would execute this attack. As the attacker, I would simply inject my cookie stealing JavaScript code into the input box, and this code calls a non-existent page on my attacking machine on port 81, and then proceeds to append the victim's document cookie value as a parameter to this page. So I'll post this comment, set up a listener on my attacking machine on port 81, and once an authenticated victim views this page, my JavaScript is executed, and I can see that we now have the victim's PHP session ID. As the attacker, I can now proceed to use a cookie editor like Cookie Manager Plus to introduce this authenticated session ID into my browser. I'll go to the Cookies Manager Plus menu, replace my useless non-authenticated cookie value with the administrative PHP session ID we discovered earlier, save our cookie, and refresh the admin page. So as an attacker, I've managed to log in to the administrative web interface of this guestbook application without entering any credentials at all, simply by using a stolen valid cookie. This attack is session specific, meaning that it will work as long as the victim user stays logged on with their original session or until their session expires. To summarize cross-site scripting attacks, these are usually leveraged to further compromise a system, be it through cookie stealing, CSRF attacks, or even by simply opening up a larger post-authentication attack surface on the web application. Let's move on to another common class of PHP vulnerabilities, local and remote file inclusions.